Hi everybody and welcome to the latest edition of Science Rules the World. All right, I wanted to start out by showing you this quote from Isaac Asimov, who was a science fiction writer as well as a scientist, because this quote of his here applies to what we're doing today. And here's what he said. The most exciting phrase to hear in science, the one that heralds new discoveries, is not "Eureka," but "That's funny." And the reason that applies to us is this. The last time we had Science Rules the World, we did a study of density of different fluids, and I dropped some ice cubes, solid water, into beakers with different substances in them. Water, isopropyl alcohol, also called rubbing alcohol, you have these at home, and avocado oil, which you can use for cooking, to see what happened with the ice cubes. All right, you probably know the ice cubes floated in water because you've had experience with that. They sank and quickly into the rubbing alcohol and slowly into the oil. And once we had finished that part of the demonstration, I just got busy doing other things and didn't get a chance to clean up right away. And I noticed that the ice cubes had melted very quickly in the alcohol and then the water, but they were still there in the oil. And something else interesting had happened. When you make ice cubes from water, from a spigot, there's air mixed in there, and the air gets frozen into the ice cubes. And since these ice cubes were at the bottom of the oil, the air that got released as the ice cubes melted tried to rise to the top because they're full of air and that is less dense, so it would float. And it got to the top of the water, but it couldn't move any higher. And so I wanted to see if I could replicate those results for you today. And we will see what happens. All right, you're also going to see how much difference in time there is in the melting of the ice in some water and in the oil. So let's watch it. And then you're going to answer the question, what is it that makes the ice locate differently in the water and the oil? Hope you enjoy watching and learn something. I did. And I'll see you in a minute as the lab goes on. Okay, so now we are going to actually do our experiment. Like you heard, I noticed something interesting when I did one of the density labs, and we're going to watch it today. And it involves some water, some oil, and some ice, solid water. Okay, unlike the liquid water. So these are some ice cubes from my freezer. Like I showed you before, they come out looking like this. Now, as you can see, do what I can to hold it. It's getting slippery. Ah! Okay, it's kind of foggy in the middle. That is because there's air in the water when it goes into the ice maker. All right, it can come out when the ice melts. All right, that's one of the interesting things I noticed. All right, so here we go. We're going to put some ice cubes. See? We have some ice cubes. Not really cubes, but ice. We're going to put into some beakers. I colored the water yellow so it matches the oil and also will help you to see what's going on. So we're going to put the ice in, then we're going to check in every once in a while and watch what happens. Okay, now here's some things we're going to remember. The density of ice is about 0.92 grams per cubic centimeter. Water is at 1. And the avocado oil is also around 0.92. Okay? And there's air trapped in these ice pieces. And the density of air is going to be less than the density of either the water or the oil because it's a gas, not a liquid. But we should see something interesting happen here. I'm going to get that started now. Okay, so here's our experimental setup. We have 2 yellow liquids and 2 thermometers. They're both at about room temperature right now, and our ice, and a timer so I can come back and check every once in a while to watch what's going to happen. I'm going to put 2 pieces of ice into each of these beakers, and then we're just going to check in periodically and see what's going on. Okay, so 2 pieces of ice go in here into this room temperature. Obviously that's the water. The ice is floating, and the ice is going to slowly kind of sink into the oil. Okay, now obviously they're both going to melt. The ice is going to melt over here, and it's going to melt over here, but we should see some interesting stuff going on. And we'll check in every 10-15 minutes or so and see what we can see about it. Okay, it needs to sit for a while, so I'm going to let everything melt for a while, and then we will come back to it. Okay, so I'll see you in a little bit. I'm going to start the timer so we know how much time has gone by when we check in again. All right, I want you to think about what's going on. Okay, and a question we're going to ask you is, all right, what do you notice? I want you to give me one thing you notice that's different about the water and the oil, which is a lipid. Okay, it's liquid at room temperature, which means it's an unsaturated fat. All for the bio students. Okay, we're going to be looking at how the temperature changes. We'll note that. We're not going to concentrate on that. That's going to be a lot of chemistry involved in there. Okay, so as you can see, the ice is just sort of floating in the middle here, and the oil, because they're about the same density, they're obviously floating at the top over there in the water, and we will come check on them again in a little while. So, and that's when I'll let you know what your question is that you're going to have to answer. Okay, see you in a bit. Okay, hi, we're here to check in a little bit. See the time? No, you can't. There it is. 6 minutes. And we can see some definite differences. Okay, the ice cubes over here in the water, as you can see, they're a lot smaller than they used to be. Okay, over here in the oil, they have melted a little. How can we tell? Because there are some little bits of water at the bottom. Let me get it closer. Okay, see these little blobs that aren't as yellow? That's the water. Now, why are they all the way at the bottom and the ice cubes are not? Because liquid water is more dense than the oil. Now, the temperature of the oil is lower. It's at about 9 degrees C instead of the 20 where it started. But the water here is down to 6. Okay, it's going to get colder. All right. So we have water on the bottom. They both have some condensation on them because they're colder than the room air. But that is not what we're going to focus on. Okay? We'll notice it more in a little while. Okay? But Okay, here's what I want you to concentrate on. Okay, all right, so why is the water on the bottom here in the oil? Because of density. Why are the ice cubes floating in the water? Because of density. Okay, why are the ice cubes melting slower over here? In chemistry, we're going to call it specific heat. But this is an indication of how come a layer of fat in an animal, like whale blubber, for example, helps to keep that animal warm in the cold. It insulates. It doesn't conduct heat as well as the water does. All right, we will come back in a little while and see how things look then. We'll get to the interesting stuff. Okay, see you in a little bit. Okay, we're back. We got interesting stuff going on over here. Here in the water beaker, we have just this little bit of ice and a tiny piece right there. The ice is almost completely melted. Over here in the oil, we can still see a couple of bigger ice cubes, which are floating higher today than they did the last time I tried this. If you remember what we saw at the beginning, you'll see that. So, this is not going to show exactly, I think, what I wanted to show. So, isn't that interesting? We'll have to think about why. Okay. All right, now you'll notice this little piece of ice is floating. These were always floating way at the top. These are kind of down in farther. They're not holding each other down. They're just in there. They're kind of sticking together now. Okay. But there goes another bit of melted water sinking down through the oil. So that will happen too. All right, so I'm going to say that about 20 minutes or so, the ice will be gone from the water. We'll check in around then, see what we think. Now, why did the ice float here? Why is the water sinking here? What's the word? That'll be your question. All right, and I'll see you again in a little bit. Okay, here we are around 23 minutes. And here's the water. The ice is gone. I'll wipe off the condensation. Ice is gone. And there aren't any bubbles in there. Right? Okay. So I'm going to wipe off the condensation and give you a little close-up. Here, we're seeing it a little bit, but not as much as I saw it before. Okay. We can see, get it in focus, some air bubbles. It's not always easy. It's not as clear as it was the first time. Right along the surface of the water at the bottom and kind of suspended in the oil. It is not moving the same way exactly. All right, maybe we'll get to see more when we check back in a little bit. See how long it takes the ice to melt. Okay, so it's like 23 minutes over here. We'll see how long it takes over here in the oil. All right, and that's when we will come back. So I'll see you in a while. Okay, here we are at 40 minutes. The ice has been long gone from the water, and the temperature is actually still pretty low in there, but not as low as before. It's about 12 degrees C. There's still ice over here in the oil. They're not big, but they're there. Here's one. There's one. So that part is doing what I expected it to do. That hypothesis is holding up, that the ice would take longer to melt. Sorry about that. And I'm going to wipe off some condensation for you so we can see we definitely have the water layer on the bottom. They're not all, but they are kind of separate little blobs of water on the top because there's a layer of oil there, and the water and the oil don't mix. Okay, that's physical property. Miscibility, do things mix together. Water and oil do not. All right, and let's watch. There goes a drop of water coming off that one ice cube. And when the mass gets big enough, it's going to slide down there. Whee, there it goes. All right, it settles in, but it does not combine with the other bubbles. Okay, so that was fun. All right, and we'll come back in a little while and see if the ice is gone. See you then. All right, here we are, 59 minutes and 55 seconds. It's been almost an hour. There it is, 1 hour. And these ice cubes are just about gone. Okay, I'll get you closer. Okay, we're about to have another little melt dripping down. So we'll wait for that. Maybe it'll happen while we're talking. Okay. And then I noticed something else that's interesting. Oh, here goes the drip. Right there. Can you see it? And that is this. Okay, and we're going to move the computer. And I hope I can show you what I want to show you. Here is the top of the water beaker. Too close. Okay, looks nice and clean. All right, but the top of the oil beaker doesn't. Okay, can you see? Yeah, you can. I can, okay. These little blobs of goo here. I don't know what these little bubbly things are. The bottom edge, let's see, move it around. Yeah, kind of sticking to the beaker. Now they're at the top. See it? There's some kind of scummy stuff. That's interesting. I don't even know what that is. Okay. The water doesn't have it, so it has something to do with the oil itself, I would think. Perhaps something's congealing. But the water is all definitely on the bottom. There is a very clear difference. Okay. Now it's colder weather. We're not using the ice as quickly, so it kind of sits in the freezer for a while. So that may be what this is from. But we have a clear line, as you can see, clear on the bottom, yellow floating on top. That I expected. And it took a long time for those ice cubes to melt compared to these two ice cubes. Also what I expected. Now why is the water down here? Why was the ice on top over here? Why was the ice sort of hovering near the top over here? What is that property of matter called? That's your question. And I'm just going to admit, there was something I saw before that I didn't see this time. So that was a little hypothesis that didn't pan out the way I thought it would. which happens. And when I used to work in research labs, it happened fairly frequently, so we had to rethink what we were doing. And I'm in that position right now. So we may come back later and see if we can replicate, do again, those results that I had before. Well, thanks for joining me for Science Rules the World. Once again, I am looking forward to doing this more with actually seeing some people in the future. Although we clearly won't be able to do something that takes an hour because we won't have classes that last that long. But I hope you learned something from this. I learned something from this. So that's always cool. All right. So why is the oil on top of the water? Why was the ice on top of the water? What's going on? That's the question to answer. And I'll see you again soon. Bye.